Good afternoon, everybody. I'm Zai Krostag. I'm a product manager, or a manager of product managers at Tableau. And I love this company. But it didn't start off that way. When I first joined, I had some doubts. It felt a little bit like they were asking me to drink some Kool-Aid. They were talking about changing the world with data visualizations, and I just wasn't buying it. Then I went to TC15. This is the one in Vegas where we rented out Fremont Street, a big screen over the thing. Anybody else go there? Yeah. That was my first experience. They said, go out there and go to this conference. And I did, and I had no idea what I was in for. And I experienced so much excitement and love and passion for this product that it blew my mind. And I knew this is where I wanted to be. I had to be part of this company because this is the dream, right? You want to be at a place where people love the software as much as we do. As much as you guys do. You know, you're the reason we do all that we do. And now, I have the opportunity to invite or introduce two of our most amazing customers, Chris DiMartini and Adam McCann. Chris runs the data visualization team at Visa. He also spends his spare time producing visualizations for Datablick. He's been a Zen Master for 2 years. He continually pushes the boundaries of what visualizations can be. He does things with our software that we never even dreamed it could do. He creates very data-dense visualizations that are still simple to understand. Adam has been a Zen Master for 3 years. He's a recognized data scientist, and he creates iconic visualizations, such as the Beatles viz that's approaching about 1 million views right now. These visualizations are a blend of both data and art. They're probably good enough to hang on your wall. So please join me with all of that love and enthusiasm that I felt at that first TC in welcoming Adam McCann and Chris DiMartini.
Good afternoon, everyone. Thank you so much for coming. And Zai, thank you for that great introduction. By way of further introduction, Chris and I are both fathers to collectively 4 daughters, 4 very data-savvy daughters who wear a lot of data clothing, as you can see here. To view this another way, Chris is raising 3 daughters, whereas I am only raising 1. And yet another, even better, arguably, way, Chris is raising 75% of our collective daughters. But those are some basic chart types, obviously. And what we're here today to talk about is advanced chart types, custom chart types, how to create anything you can imagine in Tableau. And this is a great quote from Joe Mako, one of the original Tableau Zen Masters and luminaries in the Tableau community. He said, Tableau is a data-driven drawing tool. It is something that you can use to create anything you can imagine. And you can really do this by following 3 common steps. Plot your points onto your canvas, connect those points together, and then format those points to add style and context. And that's what we're here today to talk about. All the visualizations we're going to walk through follow generally these 3 steps. The first set of visualizations we're going to walk through don't require any data restructuring at all. They just require creating calculated fields. And what we hope you take away from this is not necessarily how to create the 6 or 7 visualizations that we're going to walk through, but rather the idea that you can really do anything you can imagine in Tableau by following these steps. So I'm going to walk through, in theory, a very specific example. So I have a data set. This is created in Microsoft Excel. It's just a data set of 100 rows, ordered 1 through 100. I copy and paste it and bring it into Tableau. Probably walking too far away. And I create 3 measures. 1, a parameter that I'm going to call t, and then 2 parametric equations using that parameter that I'm going to call x and y. And then following my 3 steps of plotting points onto my canvas, dragging my x value onto my column shelf and my y value onto my row shelf, dragging ID onto my level of detail shelf, converting my mark type to polygon, and then adding ID to the path shelf to connect those points together, and then convert the color to red to create a very easily recognizable image. So this is the principle that underlies everything we're creating. Plot points onto a screen using x and y coordinates, connect those points sometimes using a path shelf or some sort of color, and then format those points to add style and context. So the first thing we're going to walk through is new chart types. These are chart types you might see in another product that aren't available out of the box in Tableau. And then the second half of the presentation, we're going to talk about really custom visuals, how to create anything you can imagine. As you know in Tableau, there are about 21 sort of standard default out-of-the-box chart types available to you in the Show Me window. You can select a combination of dimensions and measures, select Show Me, and it'll automatically create the chart for you. As you get a little more advanced, obviously, you're going to just be dragging and dropping them on your own. Thanks to the wonderful folks in the Tableau community, there are a lot more data visualizations that you can create. Cartograms, hive plots, chord diagrams. And these were charts created by other folks in the community like Chris Love, Jeffrey Schaefer, Chris DiMartini, and then were just shared on Tableau Public with how-tos, usually on their respective websites. Some of the examples we're going to walk through, an icicle chart. An icicle chart is possible to create in Tableau. It's relatively easy to do. An icicle chart is good for showing part-to-whole relationships through a hierarchy. I used this in a client setting where we had a bank. It was a very complex organization. We wanted to show the parent-child relationships of those banks and then the risk dispersed across those entities. So an icicle chart shows vertically from the top down a parent to its child to the grandchild, and then on the x-axis a distribution, in this case salary, of a continuous variable. A gauge, Stephen Few loves this visualization. A gauge is a good way of showing a point relative to a scale of points. This is possible to create in Tableau by plotting points on the circumference of a circle and then connecting those points together and then adding background images. A sunburst chart. This is a sunburst chart I created of Bill Murray movies. Every wedge is a movie. His eyes will creepily follow my cursor around as I hover. It is the creepiest visualization I made. But it is a fun one. So every wedge is size. The angle of the wedge is how much money the movie made. The length of the wedge is what was its Rotten Tomatoes score, and the color is Rotten Tomatoes score again. So a large dark blue wedge is a movie like Ghostbusters, so it's very popular, made a lot of money, and a narrow orange short wedge is an unpopular movie that didn't make a lot of money like Dumb and Dumber 2. Not surprising. All right, so the example I'm going to walk through now is a ternary plot. So a ternary plot is essentially a scatter plot with 3 axes. It is good for showing the relationship of points across 3 variables. You might use a bubble plot to do this. You would show a scatter plot with an x and y, and then put onto your size shelf or encode size as your third value. A ternary plot is another way of visualizing the same information, and it is good for showing patterns and outliers relative to a cluster. And so you see some of these examples in the New York Times and 538 of very good ternary plots. The example I'm going to show you was not created by me. I created the original ternary plot, but I actually encoded the x and y coordinates using R. Mike Cisneros, I knew I was going to mess up his name. Mike Cisneros created a better version where he actually encoded all the values in Tableau so you didn't have to bring it outside into another tool. So how do you do that? Again, we're going to follow our 3 steps. Plot your points onto a screen, connect those points together and format. So I'm going to drag my x and y into my row and my column shelf. I'm going to add in my players and my position groups. I'm going to walk through what this visualization is at the end. Add in a background image of a triangle, scale those axes, and then I have my final product. This visualization is showing NFL players and their 2017 combine results. So every player is a point. They're colored by what position group they were classified: running backs, wide receivers, tight ends. The points along the 3 axis points are how big they were, their body mass index, how fast they were, their 40 time, and how strong they were, or how much they benched at the combine. And what you can see is there's certain position groups that have natural positions across these, within these clusters. That's offensive linemen are stronger but slower, and they're bigger. Defensive backs are smaller, faster, and weaker. And this is easy to see through a ternary plot. Now, I quickly walk through these additional chart types. A great resource for not only exploring alternative chart types, but also figuring out how to create them in Tableau is the Chart Maker directory by Andy Kirk on his website, Visualizing Data, visualizing with an S. Along the x-axis is a product or a COTS solution or R or Python or an open source solution. And along the y-axis are different chart types. If you click on the points within the grid, you can actually see examples, and he'll walk you through how-tos of how to create each of these. But this is a fantastic resource. So talking about Custom visualizations, we're really talking about moving beyond standard chart types that you just can't create in Tableau, but really taking something you might have drawn, which is what I tend to do, something you might have seen or been inspired by someone else, and putting it onto Tableau, creating it in Tableau. So some of the examples I'm talking about, this is a visualization I made showing Game of Thrones and the history of characters through the series. Every color is a sigil or a family, and then how long they lasted through the course of the show. There are spoilers up there, but if you have not watched it yet, that is really not my fault. This is my Beatles visualization. It shows a Sankey diagram combined with a bar chart. This is Chris's awesome Frozen visualization, which is a series of Sankey visualizations. His golf PGA Dell Technologies match play visualization, which shows a hierarchy condensing into the final game, final match. And this is finally is my Bruce Springsteen visualization showing the history of Bruce Springsteen by albums with specific songs and which performer performed on each of these albums. But these are examples of custom visualizations. The examples I walked through before do not require you to restructure your data in any way. You bring the data into Tableau as it is. You just add measures, drag those measures onto your screen, connect them, and format them. The examples that Chris is going to walk through and then I'll follow up with require some data restructuring, and that's what we're going to talk about now through layering.
Thanks, Adam. I'm really excited to be here today to talk with you all about layering in Tableau. What are we talking about when we say layering? It's really the building of visualization and then stacking it one on top of another to get your desired visualization aesthetic. This is an example of a visualization built with layering in Tableau. It is a visualization of the PBS Kids show Word Girl. How many people in here know of the PBS Kids show Word Girl? Can I see a show of hands? You're the lucky few, it looks like. Word Girl is one of my daughter's favorite shows. It's about a young adolescent girl who has superpowers, and while she's fighting off the villains of the city, she's also teaching our kids vocabulary words. So this is a pretty dense visualization. I'm going to walk you through it. The inner ring is red circles. Those are your villains, and they're sorted in alphabetical order starting at 12 o'clock. They're sized by how many episodes they're in. The gray is the edges that connect the villains to the episodes that they're in, and the outer ring is the episodes in blue, and then all the vocabulary words that are taught within each of those episodes in yellow. We also have a hidden layer in here, which is that glowing orange look and feel that you have in the GIF. This is actually something that Johnny Walker helped me to create, so a big thank you to him to get that just right so it matched the flight trail of Word Girl from the cartoon. And that layer is represented on an action by the user. What I just showed you was inspired by this piece of work by Nadia Bremer. If you don't follow Nadia Bremer, you definitely should. Her work is incredible. And while this wasn't built in Tableau like mine was, this is probably built in D3, I think it's an amazing example of how you can compile layer after layer into a very dense visualization. And if your audience is willing to take the time to consume it, they can get a lot of takeaways from it. Layering is not something that Adam and I came up with. This isn't an original idea that we're presenting to you today. It's been done for some time now. This is an example from 2015 by Noah Salvatierra, and he presented on building chord diagrams in Tableau. That presentation also talked quite a bit about layering and things like that. So it's been around the public community for a while, and definitely a powerful technique. So what? Why do I care? Why do you keep saying the word layering? Layering allows us extremely customizable visualizations, as we've shown you already so far. So you can't quite do everything D3 can do, to be honest, but you can get a lot closer to that within Tableau. With any technique that you have, there's pros and cons. And so here's what I think they are for layering. The pros are that you can put your points anywhere you'd like on your visualization. The other pro is that you can reuse and access. So if you look online, there's often questions about how do I use a dual axis more than twice? I need to put one more piece of information on there. You can actually use layering to enable that axis over and over and over again at different levels of detail. All right, now the cons. Cons is it can get complicated, especially if you're using table calcs on top of the layering technique. Let's be honest about that, it can get tricky. You're still limited to 2 mark types within Tableau. It's the dual axis, you have 2 marks cards, you can change the mark type for each of those, that's still a limitation that you have. You can get creative with lines and polygons, as you'll see in a minute, but ultimately that is a limitation. Lastly, it requires you to copy your data. So let's talk about what that means. So here's an example of copying data. There's lots of different ways that you can copy data in Tableau. This is my go-to. This is the one that I think is easy to understand, and I can implement it rather quickly. I'm going to focus on the word girl copies data set on the screen, which is then joined to my data in Tableau, as you see on the screen. There's 4 columns in that data set: join, copy, path 1, and path 2. And I'm going to talk about them in 3 sets. So join, this is the thing that causes the Cartesian product of your data that comes into Tableau. It explodes it based on however many records you put in this file. If this file had 1 record, you wouldn't have layering, you would just have your regular data. If the file has 2 records, you now have 2 layers, the first and second record of the file. Copy is the unique way that you can identify each of those records or layers that you're bringing into your Tableau file. And this can be anything. In this case, it's an integer from 1 to 5 for my 5 layers. Path 1 and path 2 are a combination of values that you can use to actually turn densification on and off within your layers. So this is a powerful piece of this technique. And I do have to say this is based also on some of the work that Noah did back in 2015. Some of the examples that we're going to go through right now. On the left, you have the small multiple flow that I built for the NBA playoffs, and I'll talk more about that one in a second here. And on the right, you have a custom polygon KPI. And so the custom polygon KPI, really what I'm trying to get to here is we have one piece of work that may be a little bit more relevant for your work life, and another piece of work which is a little bit more creative. The custom polygon KPI gives you the capability to move data labels around wherever you want, and I'll demonstrate that in a minute. I'll take a second to describe the small multiple flow just because it's an extremely dense visualization. So this is a visualization of the 2018 NBA playoffs. Go Warriors. And what it shows is the bracket of the playoff run. You have teams on the top and bottom of each of those bracket lines. And if the team is winning the game, the point differential is in their favor. So when you see the area chart going up, that means the team that's on the top is winning. And if it's going down, the team on the bottom is winning. Each game is represented, the winner or loser of the game is represented by the background circles. And as the teams progress through the tournament, you can see whether or not they win the series and continue on to the next step. And you can also see how their games were within that series. Did they blow out the team? Did they sweep? Was it something that went 7 games? That's all things we can tell from this. Here are the layers of the small multiple flow. And here are the layers of the custom KPI. So now I'm going to do the most satisfying part of any presentation, where you get to exit out of PowerPoint and swipe it off your screen. Yeah. It's great. Okay, so the first thing we're going to do is we're going to build the first layer of the small multiple flow visualization, this one. The area charts that tell us who's winning or losing every single game in the playoffs. The first thing I'm going to do is I'm going to drag out all of the dimensions I need to set the level of detail for my visual. So the level of detail for my visual is every scoring play from every game of every round of every series of the playoffs. So I'm going to drag everything out there that I need for that. Conference, round, series, game and series, and play. And so now the level of detail of my visualization is every scoring play from every game, from every series in the playoffs. At this point, I'm ready to start dragging measures out. And what I'm going to do is I'm going to drag bracket X out as a dimension. And then I'm going to drag bracket Y. And bracket Y broke because I have some dimensions in that table calculation which aren't on the screen here. So what I'm going to do is fix that really quick by doing table across. And so this is starting to look a little bit more like what we were seeing. And bracket X and bracket Y are 2 fields that basically say, if you're at this point in the series, if you're in this game in the series, plot yourself in this place along the x-axis. And bracket y says if you're this team playing that team, plot yourself this way along the y-axis. It's just some calculations to set the x-y coordinates of where we want things to go. So this is great and everything, and it starts to look like a bracket, but you don't have a context. You can't tell what's on there. So we're going to go ahead and add color. And again, same thing. We have fields that aren't in the table calc, so we're going to just change that to table across. And at this point, we now have color that helps us represent the teams. And you can see that as I highlight this. So it's starting to make a little more sense, a little more context, but we need to finish this off. So at this point, I'm actually going to change this to circles. And I'm going to bring out path order. Now, if you remember back to when I was talking about copying the data, I mentioned path 1 and path 2. So in this case, path order is path 1 and path 2 pivoted. And so that gives me 2 rows of data. And what I do is I use those 2 rows of data to draw the 2 data points that I need. I'm going to put path order on pages. And you can see the first value of path order is like my little mini horizontal axis for my area chart across all the games across the bracket. And my second value of path order is the data point that I render against that. So to finish off this layer of the visualization, what we're going to do now is switch this to line. And I'm going to drag path order onto path. And with that, we have the first layer of the NBA small multiple flow visualization. Okay, so moving on, we're going to take a look at the rest of the layers. Here's the one we just built. The next layer that I built is the flow element. So we built the small multiple piece just now, and now this is the flow element. I'm not going to go through building this entire thing because it would take too long, but ultimately this was done in the same way. I'm building each layer on its own, and then ultimately what I'm going to do is put them together. This is the background circles. I added a border just so it was a little bit easier to see on the screen. And these really came out of a conversation with my wife. I was making her take a look at this to give me feedback. Thank you, honey. And ultimately, what she asked me that I couldn't answer from my viz was she asked me, Chris, I can't tell who's winning the series. And so I said, you know what, you're absolutely right. And that led to me building a background layer to try and communicate to the user who was winning the series. Had to add labels so you could tell which team was on top and bottom of the axis. The color wasn't good enough. It was too far off the screen. A flow element to introduce it. And then you put those all one on top of another, and you can end up with something like this. The next build I'm going to do for you is the custom polygon KPI. This is not a good dashboard, just to be clear. This is just a mess of custom polygon KPIs. This data set is from pgatour.com, and it's just the driving distance for players on the tour, sorted in descending order. So what we're going to do is we're going to build this screen. So this is the top 10 players represented as a KPI, and we're going to go ahead and build that now. I already have kind of some starter stuff on here, so I'll explain what that is. I have the player name, and I have it filtered to the top 10, and I have a filter here to focus my data on the specific type of visualization I'm going to demonstrate for you today. At this point, the next thing I'm going to do is add my layer. And so here's my layer. You can see I now have a different identifier for my layer in this visualization. I have background, bar, and a couple of points. And that'll make more sense in a minute. I also have to add 2 fields that are required just for my table calc so we don't get the errors like we did last time. And at this point, I am now ready. Oh, no, I'm not yet. The last thing I have to do is drag path order out and do the show missing values trick. So the reason why I need this is because I brought in path 1 and path 2, if you remember, as the values of 1 and 2. I pivoted it, and I created a calculation to say if it's 1, leave it as 1, and if it's 2, make it 4. Then I did the Tableau densification trick on top of that so that I can generate 4 records from the 2 that I put into the tool. Now that I've done that, I'm going to put it on the detail shelf. And so I actually have quite a few more marks here, even though you can't really tell. And the next thing I'm going to do is drag out my measures. Again, same concept. Calculations that place the x and y coordinates of all the different layers in the viz. Starting to look a little bit more like what we want. At this point, what we're going to do is we're going to dual axis the y. We're going to join that. And we are going to synchronize it. Oh, whoops. And then we're going to fix the axis to -2 and 5 because I have hard-coded into this that is the space that I expect this KPI to take up. And that's actually a liberty we can take in this situation. I'm going to hide my axes. And at this point, I'm ready to do a couple more things. So the first thing I'm going to do is I'm going to make this a circle. I'm going to make this one a polygon. And the next thing I'm going to do is I'm going to hide in my polygon. I need to hide my points. And in the point layer, I need to hide my polygon. In order to do that in Tableau, what I actually have to do is make a copy of my layer field. And I use one copy on the point marks card, and I use another copy on the polygon marks card. So I'm going to drag that out now. This is my copy. So you can see now I have 2 copies of my layers. On the mark, I'm going to hide the polygon-related layers. And on the points, on the polygon, I'm going to hide the point-related layers. So I've done that now. We just have a few more things to do, actually, to finish this up. So the first thing I'm going to do is clean up the label on the point layer. And so the way I'm going to do that is I'm actually going to cheat. And I'm going to go into here and copy it from this one. And I'm going to paste that into the label here. And then the next thing I'm going to do, what I forgot to do is drag out all the fields. I'm going to drag the fields first. Then I'm going to paste it into the label. It's always helpful if you are moving fields between labels to make sure that you have the fields on the marks card before you paste. From here, I'm going to put this in the middle, and I'm going to say always allow my values to show. So it's starting to come together a little bit. Last thing I'm going to do on this layer is I'm going to size the circles down. I'm going to make them transparent. I'm going to remove mark from color and put it on the detail shelf, and I'm going to make them white. So now my points are gone. I'm going to cheat one more time, and I'm going to copy formatting from my other sheet and paste it here, just to fix some row banding and number formatting issues. And the last thing I'm going to do is I'm going to switch this to not line. I'm going to switch it to polygon. And I'm going to drag path order onto path. And the very last thing I need to do is I need to sort that correctly. And now I have my custom polygon KPI in Tableau. Just to reiterate this one point before I wrap up, this gives you the ability to move your data labels around your visualization, as you can see here. I have complete control over where this data label goes. Same with any data label on the screen. And with all that being done, we can then generate this wonderful, gigantic, small multiple of a bunch of 192 KPIs. With that, I'm going to bring Adam back up, and he's going to show you another example of layering in Tableau. Thanks.
All right, I'm going to wrap this up. So what I'm going to be talking about is a horizon radial chart. So a horizon chart takes a line chart that has very high peaks and valleys and stacks those values and collapses them on top of one another. And this is via flowing data, but a horizon chart is good for showing compact changes over time when there's both a positive and a negative value, or 2 values that are going in different directions. So it collapses those bands on top of each other. So the dark orange is very high, the dark blue or purple is very low, and then the lighter colors is a balance somewhere in between. And so it's a more efficient use of space. A horizon radial is just taking that same concept, the horizon chart, and then turning it into a circle. So it's even more compact. It's good for showing small multiples and changes over time. Again, the low spikes indicates even odds, or a balance between the 2 values, and then dark colors indicate a spike one way or the other. And then low spikes, again, equal low values one way or the other. And so I use this chart to create this visualization, which is NFL 2018 Week 1 games and the change in win probability over time. As a New York Giants fan, this is about the only solace that I'm going to get, is making cool visualizations out of NFL play data this year, because we are not very good, as you can tell by the visualization. So what this is showing is starting at 12 o'clock is the beginning of the game, going around clockwise, and how the swing and probabilities change. You could see in the Buffalo at Baltimore game, the dark purple Baltimore, which is my wife is a fan of, was very solidly and very easily winning that game. So that's why it's a dark, thick purple all the way around. And then the little circles laying on top and the inside of the circle represent either touchdowns or field goals. So I'm going to walk through how to create this in Tableau. This is my first chart. I'm going to take these off. So what I'm going to first do is I converted my background to black just because I think that black backgrounds are cooler. And then I'm going to drag my X value. Oh, my bad. I apologize. Oh, there we go. Oh, that's going to be tricky. That's a problem. Can I get a little help? This, I don't have it on my, is there a way I can get it on my screen? Yeah. Well, I could just, no, it's just on 2 screens.
Oh, they mirrored it? Go to your displays.
Yeah. I apologize.
Not your fault. Where's your mouse?
There we go. Thank you. Sorry about that.
Now we're up and running.
All right. So, well, the first thing we do is drag our X value and our Y value onto our column and our row shelf. I'm going to convert my mark type to a polygon, which it already is, and then I'm going to drag my ID value onto my path shelf. So I now have a beautiful white blob. This is not what I want to communicate. So I'm going to drag color onto my color shelf. And now I see the beginnings of the horizon radial. And so on this chart, I am doing what Chris was speaking to, which is about layering. I layered 7 values. I duplicated this value, this data 7 times, and now I'm going to lay these values on top of one another using very similar approaches that Chris walked through. So this is every single play from week 1, so this is thousands of data points. I then duplicated this data 7 times so that I can have the layers that I want to see. And now I'm plotting those points, the same way we talked about in the beginning, plotting those points on my screen using X and Y coordinates, connecting them together by using an ID value, which connects the points on the path shelf, and then formatting them using the color values so you can distinguish between who's winning the game, whether it be the New Orleans Saints or the Tampa Bay Buccaneers. So the next step in my process is I'm going to add my scores. So I'm going to add another X value. I'm going to set it as a dual axis and then synchronize my axes. It automatically added measure names. I'm going to remove that because I don't want that. And convert my dual axis from a polygon to a circle. And I'm going to add team color to my color shelf. And score to my size shelf. So the large circles are touchdowns and the smaller circles are field goals. They're colored by who scored the play, or who scored on the play. And then what I'm going to do is create a small multiple by adding columns and row shelves. So now I have, the first one was just a single game. These are all 16 games that were played that year. And then the next step, I'm going to remove the axes, so it's a little bit larger. I'm going to add labels so you can see who the opponent was, who they were playing, where they played, and then the final score. And then my final step is to add some titles and labels so that you can understand how to read the chart. Oh, thank you. So this is good for showing compact changes over time. The same way that a horizon chart is good for showing compact changes over time linearly. This is the same. You can show a lot of visuals using a small multiple format on the screen. This is showing all 16 games. This is showing thousands of plays and 32 NFL teams. So it's a nice compact visualization that can highlight changes over time with a lot of complexity, but also a lot of detail. So the final example I'm going to walk you through, as I mentioned, I'm a Giants fan. So this is from when we were good, Super Bowl 42, which is a while ago now. But this is every play in Super Bowl 42, starting with the first play of the game at the top, going to the last play of the game at the bottom, working left to right of which direction the team was moving in. Every hop is a play. The length of the hop is how many yards they achieved. The height of the hop is whether it was a pass, it's a tall hop, or whether it was a run, a short hop. A negative loop or a down loop indicates a negative play, that they either lost yards or fumbled or received a penalty. And so this visualization, again, uses the same layering technique and the same duplication technique that Chris was walking through. This has 25 points for every single play, and that's how I create the arc, or the points between the start of my play and the end of my play. And I'm going to walk you through how to create this chart in Tableau. So the first thing we're going to do is, again, change my background to black, just because I like black backgrounds. I'm going to drag my X value onto my column shelf, my Y value onto my row shelf. I'm going to convert these to dimensions. So now I see a bunch of points. These are showing all of my hops. I'm going to put ID in the detail shelf. I'm going to convert it to a line chart, which it already is. I'm going to add path into my path shelf to connect those points together. Now I'm starting to see something that looks like my final product. And I'm going to drag color into my color shelf, move ID up, and then I'm going to add type to my size shelf. And so now the thicker line is the play itself. The thinner line indicates the length of the drive altogether. It's the bottom part, the little light gray line. A blue hop is a New York Giants play. A red hop is a New England Patriots play. The x-axis here is essentially your field and how long your field is and how many yards they gain going one way or the other. And then my y value is essentially whether it was a pass, tall hops, or a run, short hops, or a negative play, negative hops. So the last thing I'm going to do is format this. So I'm going to change the background a little bit, change the transparency, hide my axes, add a reference line to indicate when halftime started. And I also added additional marks using another dual axis to indicate when a player scored. And then my final product again looked like this. And then I add little annotations or labels to indicate what the result of the drive was or when a key play was made. This was when Manning threw a pass and David Tyree caught it on his head. It was the last time the Giants did something good. But that is the Super Bowl viz. And that is a walkthrough of how to create a custom visual, a hop chart. Thank you. So again, the purpose of this, oh no. I'll just leave this up there. I apologize. The purpose of our talk, again, is that Tableau is a data-driven drawing tool. We walked through a few specific examples pretty quickly, some custom chart types. All of these are available on our website. The nice thing about Tableau Public and the Tableau community in general is that if you want to figure out how to do something, you can go into Tableau Public, see these visualizations, download the workbooks, and reverse engineer them. Chris and I, all of our workbooks are downloadable, they're reverse engineerable, and that's honestly the best way in which I can encourage you to learn is to either go to our websites, follow the how-tos on how these were created, or reverse engineer what we did and take a crack at it yourself. But I want you to walk away knowing that Tableau is a data-driven drawing tool. You're really only limited by your imagination and what you can think of putting on the screen, and then walking through the steps using either math or data restructuring or some clever calculated fields to put those things on the screen the way you see them. So that is our time. This is Chris and I. Thank you, everyone.